Question number 1 asks us to find the absorbance if we had a 40% methanol for 20 minutes. What we need to do to answer this question is go back to experiment 3, find methanol, and what I'm doing here is comparing the 30% methanol to the 50%. There, I've got 0.24 at 30, 0.33 at 50. They wanted a 40%, so it has to be somewhere in between my two numbers of 0.24 and 0.33. That gives me an answer of choice B, 0.3. Question number 2 asks us about experiment 2. Which of the following trials would give us an absorbance closest to 0.8? So we go back to experiment 2, and I scan through the absorbances and try to find ones that are close to 0.8. Here I notice I have one at 0.76, one at 0.86, and then one at 0.82. They gave us a question that said either 10% acetone or 30% acetone. When I look at my data table, the 10% doesn't even come close. The 30% acetone for 25 minutes. In comparing that, I have 30% acetone, but not for 20 minutes. I have it for 20 and 30. Therefore, for 25 minutes, it should come out in between 0.76 and 0.86. That gives me an answer choice of H for 0.8. Question number 3 is about experiment 1. They're asking how temperature affects membrane disruption and absorpance. When I go back to experiment 1, at the top I read that membrane disruption causes the cells to release beta-cyanine. As the concentration of this solution increases, the amount of light increases. Therefore, when I go down to table 1, I notice that as the temperature increases, the absorbance rates increase as well. This leads me to choose answer A, greater membrane disruption and higher absorbances. Question number 4 relates to experiments 2 and 3. Question 4 is asking us to compare the acetone concentration and the methanol concentration with the experiment. So what I need to do is go back to experiment 2 and 3. In experiment 2, I'm going to compare the 10% acetone for 10 minutes with an absorption of 0.31 to the methanol 10% concentration, still 10 minutes, gives me less absorbance with methanol. I compare that also at 30 and 50, and I notice the pattern holds true. Therefore, we say yes, because at each concentration tested, more beta-cyanine was released in the acetone solution than was released in the methanol solution. Question 5 is asking about experiment 1. The beta-cyanine concentration was directly proportional to the absorbance, which means if one value doubles, then the other value should double. This is asking us now, trial 7 was most likely twice as great as the concentration in which sample. We go back to experiment 1, and I see trial 7 has an absorbance of 0.62. That's exactly 2 times the absorbance for trial number 4, which only had 0.31. Therefore, I'm going to choose answer B, trial 4. Question number 6 is also about experiment 1. It's asking me to identify one of the 2 independent variables and a dependent variable from experiment 1. When I go back to the data table for experiment 1, I notice that temperature and time are both independent variables controlled by the scientist, and we can tell that based on where they are in the table. They're listed first, and by the fact that their numbers jump by a logical amount. It makes sense that we would choose the temperature of 25, then 50, then 75. The absorbances, those vary, and that's what was measured. So I could say that either the temperature or the time was the independent variable, and the absorbance was the dependent variable. The only answer choice that corresponds with this is choice J, temperature for independent, the dependent absorbance.